All right, so we're continuing with section 12.1 exercises, and we are on page 759. And I'm going to do number 20. And just to recap, so what the directions say in exercises 13 through 26, sketch the curve traced out by the vector value function. Indicate the direction in which the curve is traced out. All right, so here they give us that f of t is equal to 0, t, t squared. So in the last video, we ran into a line segment and a line. Now in this video, or in this example, we have our parametric equations are x equals 0, y equals t, and z equals t squared. All right, so this is not a line or a line segment, or it doesn't look like a line or a line segment, nothing that we're familiar with. And the only reason the first one that we did in the last video was easier because x and y were both 0. But now we have y is t and z is equal to t squared. So we want things in a form that we're more comfortable with. And before we got in this class, we always would see functions in the form in terms of x's and x and y. Now in here, we would like stuff in terms of x, y, and z if we're something that we have to sketch. Parametric equations are nice, but if it's something we have to sketch, then we want stuff in terms of x, y, and z because our coordinate system is an x, y, and z coordinate system. So we don't want any t swimming around because there's no t in our coordinate system. So what we're going to do in a scenario like this is you're going to use this system of equations right there, and you're going to eliminate t. All right, so let's eliminate t. And sometimes it may require a little bit of ingenuity to do it here. All we're going to do is just take this t and plug it in. Take y equals t, and we're going to change this t right here to a y. So the fact that we have y equals t and z equals t squared, those two things coupled together gives us that z equals y squared. That is something, this type of equation we're very familiar with. Now we normally have it in terms of x and y, but it's not a big deal that we have it in terms of z and y now. This would just be a parabola. Oops, sorry. So that's just going to be a parabola. So now what we're going to do is, now what plane are we in? Normally if it were in terms of x and y and it was a parabola, then we would be in the xy plane, but given it's in terms of z and y, and we have a parabola that says we're in the zy plane. Now, this goes back to something I told you all about in chapter 11, that when you don't see an x appear there at all, it says x is a free variable. It takes on every value. And we don't see it here, but it is right there. So x does not take on every value here. So you can't forget about this. We already have been restricted to x equals 0, which puts us in the zy plane. If we didn't have that, which that would be a whole nother section, not with vector value functions, you're going to have some x. So if we didn't have that, then this would be something else, but we'll talk about that in a later section. But what I'm getting at is, don't forget that you still have x equals 0, which puts this in the yz plane. So we're in the yz plane. And now we're going to sketch this. And I'm not going to sketch it in 3 dimensions. I could, but it's not necessary. If we're in some plane, we'll sketch it as such. So convention in a plane is that the letter that's closer to the end of the alphabet is because we have x and y normally, so we'll do the same. We'll use that same convention here, and we'll put z right there, and we'll put y right here. So in the xy, if this were in the xy plane, and we had x equals y squared, if we were in the xy plane and we had x equals y squared, that's a little bit different from this. So you're kind of going to look at this more as what we're accustomed to having. And in the XY plane, we're accustomed to having y equals something for our function. But now we're in the ZY plane. So what we're accustomed to would be, what we would use a convention would be z equals something as our function. So this is in its usual form that you're accustomed to, which says this parabola is going to open up. Now, you could instead just plug in points and figure it out versus using your knowledge of parabola, which we still are going to have to plug in points anyway to figure out our direction of travel here. So when I say plug in points to figure this out, which way this opens, you can take y values, which are your independent variables here, plug it in and get your z values. And you will see that that parabola opens up like that. And remember, your options will only be up or your options usually for a function would be up or down, but now we're sketching curves. So we could have a parabola opens to the right, opens to the left. Although they're not functions, they are curves, and we're focused on sketching curves, not necessarily functions. So at t equals 0, what do we get? We go here now. At t equals 0, we get 0, 0, 0. And remember, this function is what's tracing out our curve. So any point, any t value will give us a point x, y, z on the curve. So we'll be at the origin there. And remember, our x is always going to be 0 because of that. So yes, this is a three-dimensional point, but this plane that we're drawing in is the yz plane. So this is the x equals 0 plane that we're drawing in. And t equals 1. Just plug in any other point. There's no restriction on t, so pick any points you want to. And t equals 1, we're going to get 0, 1, 1, 0, 1, 1. So we end up, we'll say, right there. So that says our direction of travel is in this direction. And then the rest of your arrows, you draw the same way. So remember, again, don't put arrows here. Otherwise, it's misleading if you put an arrow right there and an arrow right here. All right. Next, let's look at number 22. So number 22, same directions. Here our f of t is equal to 2 cosine t, comma, negative sine t, comma, negative 3. And t varies between negative pi and 0. All right, so I like to use this, and then I still, although it's apparent there, I still like to write down the parametric equations. So I like to see that x equals y equals z equals, and then z equals negative 3. All right, so now here, now remember I said we would like to eliminate t in some shape, form, or fashion if we could, and just have everything in terms of x, y, and z. So the last one was a little bit easier to eliminate t. This is going to require a tad more ingenuity. So when you see cosine and sine in a problem, 9 times out of 10, you're going to think you should think of what I'm going to make your favorite trig identity, cosine squared theta plus sine squared theta equals 1. And you want to try to squeeze that out of a problem if you're trying to eliminate your t, because we know in that trig identity, or cosine squared of t plus sine squared of t equals 1, we know in that trig identity, one side doesn't have any t's in it at all, so the t's have been eliminated. So we're going to try to do that same thing here. So if I rewrite this as, I want to just isolate cosine t here, I want to isolate sine of t here, and then I'm going to use that trig identity. So this is x over 2 equals cosine of t. This is the same as negative y equals sine of t. And I can't forget about my z equals negative 3. So At this point, I don't need it right now, but as we go further, I can't just ignore that and say, okay, Z is just anything or make Z something other than what they told me it was. Now, I'm going to use my favorite trig identity, which is cosine squared t plus sine squared t is equal to 1. So, but that tells me that this squared plus this squared has to be equal to 1. So let's say x over 2 quantity squared plus negative y quantity squared equals cosine squared of t plus sine squared of t. And I know this is equal to 1. So now I can just drop this part off and I know that this then is equal to 1. So that gives me x squared over 4 plus y squared equals 1 and z equals negative 3. So now we've eliminated our t, and now we can go back to whatever class we learned conic sections in, whether it was algebra 2 or I don't remember what class you learned conic sections in, but this is going to be an ellipse. And I also, another thing I can't forget about, which sometimes I'm guilty of, my t's. All right, so this is actually not going to be a full ellipse, I don't think, from that right there. But we'll use our t's to figure out it's going to be some portion of ellipse. It could be a full ellipse. All right, so now, if you don't remember how to sketch anything that you come up with here once you eliminated your x and y, you can always go back to the rudimentary approach of just plugging in points. That's never going to fail you. So always go back. If you're like, I don't know what this thing is, just start plugging in some points and that'll do you just fine. So plug in some x values, see what corresponding y values you get for those x values, and eventually you'll figure out what your figure is. So this would be an ellipse. I'm just going to get a portion of it, so we'll see what we get here. Now, we're not actually in the xy plane, but we're in a plane that's parallel to the xy plane. So I'm not going to sketch this in 3 dimensions, but same thing I could. But because I'm in a plane z equals 3 that's parallel to the xy plane, I'm okay with sketching this on my sheet of paper in 2 dimensions and then just specifying that I'm actually in the plane z equals negative 3. So x, y, and this is the plane z equals negative 3. So it's apparent to, it's apparent to anybody that's looking at this. This is not the plane z equals 0, the usual xy planes. The xy plane shifted down 3 units. All right, so now what I'm going to do is I'm going to sketch. So if I were to put in, let's say I put in, and I'm going to do some y's instead of some x's just to make my life a little bit easier. For y equals 0, what am I going to get for x? When y equals 0, I'm going to get x equals plus or minus 2, because the 4 will go over to the other side. So I'm going to get negative 2 and 2. And I'm not going to sketch anything yet because some of these points may not be on here because I have to go back to this. And if, I'm going to do the same thing. If x equals 0, y would be equal to plus or minus 1. So actually, instead of even putting points there, let me just put hash marks. So this is 1, that's negative 1, and then we'll put in the points that actually apply. All right, so now this would be that ellipse if I were to plot those points and then just connect all of those with an ellipse, then that would be the entire figure. But I need to pay attention to this. So let's just plug in some points. So at t equals negative pi, what do we get? At t equals negative pi, right here, we put those in here. So 2 times cosine of negative pi. Cosine of negative pi, same as cosine of pi, is negative 1, and then times 2. So I'm going to get -2, comma, and then negative sign of negative pi is the same as the sine of pi, which is going to be 0. And then z is always -3. So at t equals negative pi, I already know my z was -3. That is what I drew. My x is -2 and my y is 0. So I'm right there at t equals negative pi. Now let's do t equals negative pi over 2. You don't want to jump to t equals 0 because for just our luck, t equals 0 is going to put us right there. Then we don't know if we should be going this way or should we be going that way. So you don't want to just jump from one end to the other in your interval. You want to do something in between to make sure that you actually are going in the right direction. So t equals negative pi over 2 I'm going to do. And t equals negative pi over 2. Take that and I put that in here. So cosine of negative pi over 2 is the same as cosine of pi over 2, which is 0. So x equals 2 times 0, which gives us 0. And then negative sine of negative pi over 2 is the same as sine of pi over 2, which is 1. And then my z is always -3. So at time t equals negative pi over 2 and I'm moving in the positive direction along this interval, I'm at 0, 1, -3. So I'm going to be right there. And I know that at t equals 0, I think I'm going to stop here. So at t equals 0, where will I be? Yeah, 2. So yeah, I'm going to be at x equals 2 at t equals 0. So I'm going to take this last one, plug it in right here. I'm going to get my x equals 2, which is telling me I'm stopping right there. So I'm only going to have this portion, that portion of the ellipse, and it's moving in this direction because I started here and then there, and it's where I end. All right, so I'll stop this video here. I'm going to do one more. I'll probably do one more example in detail from this section, and then I'm going to go over what I was discussing when I said just identifying things just in writing, not necessarily going through the entire sketch.